Hello guys, welcome to Physics Grad. In this video we are going to see how a general line integral can be written as an integral of a vector or in terms of dot product of vectors, and that is what we are going to see. So let us begin. So for this, let us start by considering a vector. Consider a vector which is dependent, whose value and direction is going to be dependent on x and y, and this can be given by u equal to p xy, some function along the x direction, plus q xy with the j direction. So this implies that the x component of u is a function p which depends on x and y, and y component of u is a function q which depends on x and y. Okay, then the line integral given by integral c, that is over a curve, p dx plus q dy will be given by integral over the same curve ut ds, where I'm going to explain what ut means. So here ut is nothing but the tangential component of u to the curve. Okay, and ds is nothing but infinitesimal arc length, and this should also be along the direction of u. So to understand this, let us first consider a part of the curve like this and a small segment ds. This is the arc length. Okay, so as the limit ds tends to 0, this quantity will be very close to a straight line. So if I zoom out or zoom in, I will get a line whose length is ds, and which means I can form a right angle triangle, and this will become dx, this will become dy, and if this angle is alpha, then we have dx by ds is equal to cos alpha, and dy by ds is equal to sin alpha. And let me define a unit vector in the direction of the tangent as the vector t hat. Okay, so this is going to be tangential to the curve at a point which lies inside the arc length element ds, and as the arc length element tends to 0, this is same as saying that this tangential vector t hat is a vector which is parallel to the tangent at the point which is inside ds. Okay, and when we take the limit ds tends to 0, the point and ds coincide. So this implies that our t can be written as mod t cos alpha I cap plus mod t sin alpha j cap, where I cap and j cap are the unit vectors along x and y axis. So, but since we are considering this to be a unit vector, this is going to be 1. So this implies that our unit vector t is nothing but cos alpha I cap plus sin alpha j cap, which by using these relations can also be written as dx by ds I cap plus dy by ds j cap. Okay, so this implies that our ut is going to be the dot product of u with the tangent unit vector. So this is nothing but p I cap plus q j cap dot dx by ds I cap plus dy by ds j cap. which is nothing but p dx by ds plus q dy by ds. Okay, and what we are trying to prove here is that this quantity is equal to, these two quantities are equal. That is what we are trying to prove. So if I consider this guy here, this becomes integral c ut ds is equal to integral c p dx by ds plus q dy by ds, which is nothing but integral c p dx plus q dy. So therefore this kind of a line integral can be written in terms of the tangential component of the vector u along the curve integrated with respect to the arc length. Okay, so this is the first way in which we can express the line integrals as integration with respect to some vector. Okay, now we can also write integral c p dx plus q dy. Here c represents the curve. This is equal to integral over the curve u dot dr. Okay, where I define dr vector as dx I cap plus dy j cap. Okay, so if we define dr as in this form, then this quantity can be written in this form, because the dot product of u with dr is going to give the same quantity here. Okay, so this implies that u dot dr is equal to, if I write it as a limit of summation n tends to infinity, summation over I equal to 1 to n u vector of xi star yi star dot delta ir, where this xi star yi star, all of these are having the same meaning as what we have seen before. So what those xi star yi star mean is that if I have a curve like this which is divided into n parts, and if this is the coordinate xi minus 1, yi minus 1, and this is the coordinate xi yi, then xi star yi star is nothing but some coordinate in between these two coordinates. Okay, and here delta ir vector is nothing but delta ix x cap plus delta iy j cap, where this is xi minus 1. Similarly for delta iy. Okay, so this is another way of writing our general line integral in terms of vector integral. Okay, now if c is, or before that, we can also write integral c u dot dr, which is nothing but integral p dx plus q dy, as equal to integral over c u dot dr by ds. Okay, nothing changes here. So which implies this is, if we compare it with what we have written here, so where is that? Yeah, so if you compare this equation, so this, when I integrate it with ds, this must be equal to ut. So here this should be equal to ut ds. Okay, and if c is represented in terms of a parameter t, okay, then we can write integral c u dot dr as equal to integral over c p dx plus q dy this already we have established, which is equal to integral of from h to k over c, of course, p dx by dt plus q dy by dt times dt, which can be written as integral from h to k c u dot dr by dt, where this h to k means that if we are going from a to b here, then correspondingly the parameter t goes from h to k. Okay, that is what this means. Alright, so here you will understand these notations better if you have watched my previous video. So I might forget sometimes to explain what the notations are. So this is because I am assuming that you have watched my previous videos as well, but as far as possible I will try to explain what the notations are. So moving on. So in this manner, if we can express our curve in a parametric form, then we can express this integral in this form as well. Oh, dt is missing here. Alright, so next we will consider another way of interpreting our general line integral. So integral c p dx plus q dy can be interpreted as a vector integral in another way, which is given by the following: integral c v dot n hat ds is equal to integral c vn ds, where initially we had defined the vector u as pi cap plus qj cap. Here I am going to define this vector v as qi cap minus pj cap. Okay, and n hat is nothing but is a unit vector perpendicular to the unit vector t and 90 degree behind t. So what I mean by 90 degree behind to t is that if we have our curve like this and if we have t hat like this here, then n hat is 90 degree behind, in the sense you have to go 90 degree and 90 degree clockwise. Okay, because anti-clockwise is considered positive direction for angle, so we are going behind, which means we have to go anti-clockwise. So n hat will be a perpendicular vector to t but 90 degree behind, so it will have this form. And this n hat can be given by the cross product of t with the unit vector along z direction or perpendicular to x and y direction. So this can be given by, as we already saw, t hat is given by this vector. So our n hat is going to become dx by ds I hat plus dy by ds j hat cross k hat, and using our cross product, this will become dy by ds I cap minus dx by ds j cap. So if we substitute this for n hat over here, what we will get is that integral v dot n hat, which is n hat ds integral over c, which is vn ds over c, becomes integral over c q I hat minus p j hat dot dy by ds I hat minus dx by ds j hat times ds. So this will become integral c q dy by ds plus p dx by ds ds, which is nothing but our original integral p dx plus q dy. Okay, So therefore this is another way of interpreting our integral in the form of a vector integral of this form. Okay. So similarly, let us just find what is the result of the component of the vector u along this normal unit vector. So what will this be equal to? This will be equal to integral c p. So this is actually equal to u dot n hat ds, which is integral c p I hat plus q j hat dot dy by ds I hat minus dx by dy j hat. So this will give us integral over c q dx minus p dy. So this is what we are going to get. If this is because u is pi hat plus qj hat and n hat is dy by ds I hat minus dx by ds j hat, and when we take that cross dot product, we will get this particular quantity for the integral. Okay, so we have covered almost all possible interpretations of the general line integral as a vector integral, and this is what I wanted to do in this video. So thank you for watching. See you next time.